So my name is Raymond, and I'm going to take you through the third performance criteria of the element that states that components of an infrared spectrum are listed. And right away, I'm going to list the components of an infrared spectrum. And I'm going to start with the first one being the IR source. The second one is a monochromator system. The third one, we have the sample. The fourth, we have the reference. Fifth, we have the splitter. Sixth one, we have the detector. And the seventh one, we have the display or the readout. I just want to clarify one aspect. As my colleagues that have come here before, they've talked about the Fourier transform infrared spectrometer, and we have also the dispersive infrared spectrometer. I just want to highlight the fact that the difference come here, whereby in the dispersive one, we use a monochromator as a way of splitting the wavelength from the IR source. But for the Fourier, we use the interferometer to split the wavelengths that comes from the infrared source. So that is the only difference that I would like us to get it, so that you can differentiate between the two spectrometers. So maybe I can just run you through the functions of maybe these components that I've listed. And I'm going to start with the IR source, whereby this is where we get the infrared source from. And we have several sources of the infrared, which I'm sure you know some of them. Maybe I can get one or two from you. Anyone? Any source of an infrared? Yes, Obed? Tungsten. Very good. Another one? Yes, Fancy? Globa. Very good. So those are some of the sources of the infrared. And once we've gotten the sources, then we go to the monochromatic system for this dispersive, where there's a splitting of the wavelengths. And after that, we have the sample and the reference. And then from there, we go to the splitter, where the intensity of the splitter is where actually the incoming IR beam are split into two equal parts. You see this one, they're equal actually. So this one, they are split into two equal parts, which are going to the detector. And then from the detector is where it measures the intensity of the infrared light that has passed through the splitter. So this is where the intensity of the infrared is measured. And then finally it goes to the display, where you can see how the infrared are being displayed, as you can see from this flow chart or diagram. So up to there, I think we've covered the components of an infrared spectrum as listed on the whiteboard. So thank you, and I'm going to welcome any other member from my group to continue from there.
Okay, good afternoon. For now, I'm going to take you detail more the components of an infrared spectrometer in details, because my colleague has just listed in some functions. So for now, I'm going to deal with mostly the components. For example, we are going to start with the IR source. As Zia said, we have different types of the IR sources, such as the NAS resource, then the global source, then we have the tungsten, then the mercury arc lamp. I think when maybe doing this analysis, you have to choose the best, because maybe these types of IR sources have the advantages and disadvantages. And for example, the marker pen. For example, the NAS glower, its description is that glows when heated. Then the global source, the description is that the silicon carbide rod is more used than the NAS glower. Then the tungsten, mostly similar to the bulb filament. Then the mercury emits its fire, the IR. No, it depends on how this IR, for example, this IR, it depends on the wavelength. Because in the NAS glower, the wavelength range from 400 to 4,000 to 400 centimeters. Then this one is the mid. Thank you. For example, this one, let me write here. For example, the NAS. Now, these are the four sources in which we can use to obtain the IR. So I think, yeah, for according to my opinion, which one between this one and this one, which one is more, which can be used? Which one? This one or this one? This one, because it's near the IR. Maybe it can easily detect the wavelengths, and maybe during analysis it can. These ones are the sources in which you can use during your maybe. No, this one is the wavelength in which it can access. Yeah, these ones are the sources of types of. No, sorry, the sources of IR. Yeah, yeah. Now we are going to the sample handling system, where this is allows the IR beam to interact with the sample. And obvious sample can be in three ways. It's in a gas form, liquid, and the solid. I think we never went detail there. Then the monochromator, the purpose is disperse the IR radiation into the components wavelengths. For which I know the type of the monochromator uses electricity, right? Then we have the detector. detects the IR radiation after the interaction with the sample. I hope that's understood. Then we have the common types of detectors. We have the thermocouple, then we have the balometer, and then the bioelectric detector, and then photoconductor detector. And so I think those ones are the most can be encountered maybe during the analysis there. Then we have the signal processor and the recorder. It converts the electrical signals from the detector into the visible spectrum. I hope I don't need more explanation because it's just a part of explanatory. Then the other one is the optical component. This includes mirrors and lenses used to focus. For example, in our diagram, these ones are the mirrors. If you can reflect it, then I can put a sample and then I think that's our now. Then you have my colleague to tackle on another topic. Thank you. Good afternoon. So, I'll discuss on chromatic and non-chromatic techniques. So, chromatic techniques, they are based on separation of components in a mixture. Then, non-chromatic techniques, they are based on detection, on quantification or identification without viscous separation. So, the chromatic techniques that are based on separation. Components in a mixture. Then the non-chromatic So on classification of chromatic mechanism, we are categorize it into two. Number one, based on physical state or mobile phase. Sorry.
based on physical state of mobile phase. So on type, gas chromatography and liquid chromatography. Number one, based on mobile phase. The type gas chromatography. The mobile phase for gas chromatography is gas, then the stationary phase is liquid or solid. Then for liquid chromatography, the mobile phase is liquid, then the stationary phase is solid or liquid. Number two, based on separation mechanism. The example are adsorption chromatography, which is TRC, and column chromatography. Then partition chromatography, example are paper chromatography and GFC. Then on partition, on ion exchange chromatography, examples are separation of ions and polar molecules. Then on the affinity chromatography, example, the antigen, antibody, and enzyme substrates. The last one is size exclusion, that's gel filtration. Examples are the separation by molecular size. Welcome my colleague for the chromatographic techniques. Thank you. Okay, good afternoon. Okay, I'm going to take you through chromatography techniques. Okay, we are tackling the chromatic and non-chromatic techniques. And in chromatic techniques, we have the chromatographic technique, which my fellow teacher tackled. Okay, we have on the chromatography, we have the paper chromatography. The type of paper chromatography uses this type of technique, which is partition. What is partition, may I ask? And by the show of hands. Okay. Yes, thank you. It is the distribution of a solid between two immiscible phases. That is the stationary and the mobile phase. Okay, in these phases, the paper chromatography uses the water in the paper fibers, while the mobile phase uses the solvent. It can either be water or alcohol. The main importance of this technique, where it is mainly used in the separation of pigments and also in the case of amino acids. Okay, another chromatographic technique is thin layer chromatography, which the type of technique it uses is the adsorption. Okay, I can ask also, what is adsorption? Yes.
Adsorption is that ability of a substance to stick. Yeah.
Yes, that's it. attach itself. Yes, thank you. Okay, in this case, the stationary phase used in thin layer chromatography is the silicate gel or aluminum on a plate. The mobile phase is the organic solvent, and it is mainly used in qualitative analysis and reaction monitoring. Okay, another chromatographic technique is column chromatography. The type it uses is absorption also, and also the stationary phase is the silica or aluminum packed in a column. Okay, and it's mainly used in the isolation and purification of compounds. That is column chromatography. Another chromatographic technique is gas chromatography. Also uses the partition. Here, in the case of gas chromatography, it uses partition. The mobile phase is inert gas. It can either be helium or nitrogen. The stationary phase is liquid or on solid surface. Alafu its use is analysis of volatile and thermally stable compounds. Okay, another chromatographic technique is high performance liquid chromatography, which uses either the partition or adsorption. The mobile phase is liquid under high pressure. The stationary phase is the column with silica or polymer kits. Okay, its use is used in drug analysis, proteins, and food compounds. Okay, the last one is the ion exchange chromatography. The mechanism which includes the exchange of ions between solution and charged resin. The stationary phase is the ion exchange resin, that is the cationic and the anionic. Okay, its main use used in the case of amino acids, proteins, and water purification. Okay, thank you for your
So chromatic techniques do not involve light. The chromatic technique it involves the use of light, but this one does not involve the use of light. But instead, it uses physical, chemical properties such as mass to measure the mass of a substance, charge, conductivity, or thermal properties, which is thermal is related to the amount of heat. So the first chromatic technique is potentiometry. Do we understand by potentiometry? You can give us a definition. Potentiometry. So potentiometry it is used to measure the potential difference between two electrodes. So we have permanent electrode and then we have indicator electrode. For reference electrode it is used to provide the stable non-sample, while for indicator electrode it is used to respond to the analyte. The next technique is potentiometry. Potentiometry is the ability of a solution to conduct electric current. It also monitors chemical reaction or determine the concentration of ion. Another non-chromatic technique is gravimetric analysis. Who can give us a definition of gravimetric analysis? So gravimetric analysis is a quantitative analysis technique used to determine the amount of substance by measuring its mass. So these are for gravimetric analysis. You know there is a step for gravimetric like sample preparation. We prepare the sample. Then the next step is precipitation. Next step, kuna filtration. Yeah, those steps, I think it is the eighth step. That's on a sample preparation, kuna precipitation, kuna ignition, filtration, all of that. Alafu next is voltammetry. It is used to measure the current. Alafu next technique is calorimetry. It is used to measure the quantity of it. For example, we use Q. Q is equal to Cp or what? So in it, this one is Q is the charge, along this one is the current,